This title tells us the quiz focuses on how different ways of linking data points, linkage criteria, affect the results of a specific clustering algorithm called agglomerative clustering. I'll be testing your knowledge on this. Let's dive in. This is the core of the quiz. It asks you to identify which statements correctly describe how different linkage methods influence agglomerative clustering. You'll need to understand the characteristics of each method to answer correctly. This question sets the stage by letting you know that you'll be evaluating several statements about how the different linkage criteria affect the clustering outcome. Think carefully about each one. These are the correct answer choices. After reviewing the explanations, you should see why these options are correct and the others are not. It's a multiple-choice question where you select all options that match the properties of the linkage criteria discussed. This is one of the linkage criteria used in agglomerative clustering. The Ward method aims to minimize the variance within clusters. I will explain more about this in the following steps. Another linkage method, complete linkage, uses the largest distance between any 2 points in different clusters to decide which clusters to merge. This makes it less prone to errors caused by outliers. In average linkage, the average distance between all pairs of points in 2 clusters is calculated to determine how similar the clusters are, and whether they should be merged. It provides a balance between single and complete linkage. This linkage method uses the smallest distance between any 2 points in different clusters when deciding which clusters to merge. However, because it uses the minimum distance, it is susceptible to errors caused by outliers in the data. So think carefully about this one. This quiz tests your knowledge of how different methods of linking data points affect the results of agglomerative clustering, a technique used to group similar data points together. I'll explain the different methods and how they work. This question asks you to identify which statements correctly describe how the choice of linkage method influences the clustering results. Let's dive into the details. The Ward method aims to create clusters with similar amounts of data spread within them. I think of it as aiming for equally spread out clusters. Outliers are data points that are unusually far from others. Complete linkage looks at the largest distance between data points in different clusters, whereas single linkage uses the smallest distance. Because of this, complete linkage is less affected by those pesky outliers. The average linkage method is pretty straightforward. It calculates the average distance between all pairs of data points in 2 clusters before merging them. It's like averaging all the distances. This statement is incorrect. The way you link clusters, the linkage criteria, does affect how many final clusters you get, not just their shape. The number of clusters is often preset, but the linkage method still affects which points end up together in each cluster. I'm going to explain the different ways we can link data points together when we're doing agglomerative clustering. Think of it like building a family tree for your data. You'll start with individuals and group them based on their similarities. We'll explore 4 common methods: Ward, complete, average, and single linkage. Each method has a unique way of measuring the distance between groups. It's like choosing the right tool for the job. This question tests your understanding of how the choice of the linkage method affects the final result of the clustering process. The core concept is the impact of how we measure distances between groups of data when building our hierarchy of clusters. We will analyze the effect of each linkage type on the clustering outcome. I'll explain what this means. Ward linkage tries to minimize the total variance within each cluster. This means it aims for groups where the data points are densely packed together and each cluster is about the same size and spread out across the data. Imagine it as creating equally sized, compact little neighborhoods. Here, I'm comparing 2 linkage methods. Complete linkage uses the largest distance between any 2 points in different clusters. This makes it less affected by extreme values or outliers. Single linkage, on the other hand, uses the shortest distance, making it easily swayed by outliers. Think of a party. Complete linkage is like inviting everyone based on the furthest distance among the guests, while single linkage invites based on who's closest, regardless of who's far away. The name says it all. Average linkage calculates the average distance between all pairs of points in 2 clusters to decide whether to merge them. This approach is more balanced than single or complete linkage. It's like taking the average grade of 2 classes before deciding to combine them. Let me clarify the misconception here. The linkage method hugely impacts the shape and asterisk organization of the clusters. It influences how the data points are grouped together. While the total number of clusters might be predefined, the actual composition and structure will vary greatly depending on which linkage is used. It's the recipe, not just the number of cakes. I'll explain the different ways we can link clusters together in agglomerative clustering. Think of it like building a family tree for your data points. Each method, ward, complete, average, and single, decides how we measure the distance between clusters to decide which ones to merge at each step. This is a quiz to test your knowledge of how different linkage methods affect the results of agglomerative clustering, a technique for grouping similar data points together. This question asks you to identify which statements correctly describe how different ways of measuring distances between clusters affect the final groups that agglomerative clustering produces. I'm assessing whether you understand that ward linkage aims to create clusters with similar amounts of spread or variation within each group. It's like making sure your teams are evenly balanced. Here, I check if you understand that complete linkage, which uses the maximum distance between points, is more resistant to the influence of unusual data points compared to single linkage, which uses the minimum distance. I'm evaluating your knowledge of average linkage, whether you know that it uses the average distance between all points in two clusters to decide how similar they are. It's like taking the average score of two teams to compare them. This assesses your understanding of how the method of linking affects the overall grouping structure, even the number of groups formed. Think about how changing your grouping approach can yield quite different results. I'm focusing on how different ways of linking data points affect the results of agglomerative clustering, a method used to group similar data together. It's like deciding how to connect the dots to form meaningful shapes. Ward linkage aims to create clusters with similar amounts of spread or variation within each group. Think of it like making teams for a sports game. You want each team to have a similar level of skill. Minimizing variance makes the clusters more uniform. Complete linkage considers the farthest distance between any 2 points in different clusters. Outliers, being far away from other points, don't heavily influence the clustering because I'm looking at the largest distance rather than smallest distance like single linkage does. Single linkage is much more easily swayed by an outlier. Average linkage computes the average distance between all the data points in 2 clusters to determine how similar they are. I'm averaging out the noise to get a good idea of the general distance. It's a more balanced approach compared to complete or single linkage. This statement is incorrect. The linkage method influences how the data gets grouped, which directly affects how many final clusters you'll end up with, and their overall arrangement. The number of clusters isn't always fixed. This quiz tests your understanding of how different methods of linking data points affect the results of agglomerative clustering, a technique used to group similar data. It focuses on 4 key linkage criteria: ward, complete, average, and single. Let's dive in. This question asks you to identify which statements correctly explain how the choice of linkage criteria, ward, complete, average, or single, affects the outcome of the agglomerative clustering algorithm. You'll need to apply your knowledge of how each method works. Ward linkage aims to create clusters with similar variances within each cluster. I minimize the total variance across all clusters. This usually results in clusters that are relatively evenly sized and don't differ greatly in their spread of data points. Complete linkage uses the maximum distance between any 2 points in different clusters to decide how to merge them. In contrast, single linkage uses the shortest distance. Because of this, complete linkage is less affected by outlier data points that might create artificially close clusters in single linkage. I use the average of all pairwise distances between data points in the 2 clusters being considered. It provides a more balanced approach compared to the extremes of single and complete linkage. This statement is false. While you often set the number of clusters beforehand, the way data points get assigned to those clusters depends heavily on the linkage method. Different linkages can yield significantly different cluster shapes and structures. This instruction indicates multiple choices are correct. This is simply a label indicating the options provided in the quiz. This title tells us we'll be looking at how different ways of measuring distances between groups, linkage methods, affect the results of agglomerative clustering, a method for grouping similar data points together. This section poses a multiple-choice question testing your understanding of how different linkage criteria in agglomerative clustering affect the final clusters. This section introduces the core concept: different ways to calculate the distances between clusters in agglomerative clustering. We'll examine several methods, which I'll explain further below. Ward's method aims to minimize the variance within each cluster. I like to think of it as trying to create clusters that are internally very homogeneous, similar to each other. The complete linkage method uses the largest distance between any 2 points in different clusters. Imagine it's looking for the most distant pair of points to represent the distance between 2 groups. This makes it pretty robust against outliers. The average linkage method calculates the average distance between all pairs of points in 2 clusters. It's a good balance between the other methods, considering all the distances. The single linkage method uses the shortest distance between any 2 points in different clusters. This method is very sensitive to outliers because it only cares about the nearest pair. Statement A accurately reflects that Ward's method results in clusters with similar variances because that's its primary goal. Statement B correctly states that complete linkage is less affected by outliers compared to single linkage because it considers the maximum distance, not the minimum. Statement C correctly defines how the average linkage method works, by computing the average distance between all pairs of data points from the 2 clusters being considered for merging. Statement D is false. While you often predefine the number of clusters, the linkage method significantly affects how the data points are grouped into those clusters.